Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Hi guys, so today we will be looking at chapter 12, which is on time series forecasting, our final chapter of our subject. Basically, time series forecasting is all about you analyzing time series data, its components, being able to calculate trends and interpret them, forecasting time series data, and then finally how you use such models in business. So first of all, let's look at what's a time series, a definition. So time series is a series of figures or values recorded over time. Any pattern found in the data is then assumed to continue into the future and an extrapolative forecast is produced. Examples: output of a factory every day for the last month. Now that the time is last month, the series is output of the factory every day. Monthly sales over the last 2 years. Well, you could say the time is 2 years, but the series is monthly, and what's the data? Sales. So the series is monthly and time is last 2 years, and data is also part of series, um, which is in this case the sales. So likewise only we analyze time series data. So if you look at this chapter, they've divided time series into 4 parts: trend, seasonal variations, cyclical and random variations. So, if you look here, trend has to be calculated, and we can use 3 methods to calculate trends. That is line of best fit, linear regression and moving averages. We will learn that in this chapter. Additionally, under seasonal variation type, we have to learn how to interpret additive and multiplicative model. We don't have to learn how to calculate it, but I will explain how to calculate it, because then only we can understand clearly how to interpret. And that is it for this chapter, and we will have to just know the meaning of cyclical and random variation. So let's now just look at an overview of trends. So trends have downward trends. You might know, when the graph goes this way, it's a negative correlation, or something negative. So it's a downward trend, because as the years are increasing, the labor output per labor is reducing. That's why it's called downward. And upward trend is because as the years are increasing, the cost is increasing, hence called an upward trend. Well, this one is a static, or they call it a level trend, where it doesn't go as a slope onto any side. It's just as a, like a straight line shape, but not a straight line, but in the angle of a straight line, like the fixed cost angle, which is a horizontal line. Same way, that type of trends or graphs are called static or level trends. So that type of graphs are called as static or level trends. Seasonal variations means the variations or the changes that occur due to the season. Maybe summertime, winter season, rainy season. Because of those other factors, seasonal factors, changes may occur. That's an overview of seasonal variation. Cyclical variations are changes occur due to economic changes. Mostly like when a country is in the boom period, where the economy is doing very well, then the cyclical changes may be more positive. Okay? But if they are in a recession or we call it a slump, then they are in a negative variation, but that variation is called cyclical because they come in cycles because not always does an economy is favorable. It has its ups and downs. So since those ups and downs come rotationally, we call it cyclical variation. So, but we don't have to calculate anything for this variation. So, just knowing the definition is enough. And then random variation. Random variation is also known as irregular variation, where one-off changes in a time series that are caused by circumstances will not necessarily repeat. Example, tsunami. The changes that happen because of tsunami. Okay, so those are called random. Why? Because tsunami came only, I think, once or twice. So to Sri Lanka. So that's a random event. If it comes not very often, and if it's like a one-time thing, we can define it as random variation or irregular variation. COVID also can be one of the irregular variation. Okay, now let's focus on calculating trends. Back to the Excel sheet, you'll see this breakdown and you'll see that we've already learned a line of best fit under chapter 9 or chapter 11 as well, linear regression under chapter 11, and finally what we have to learn in chapter 12 is moving averages. Moving averages basically gets the average of results of a fixed number of periods and it attempts to remove seasonal effects. Let's see how to calculate them. So in your moving average, you will have a format like this. So these two will depend on the question, but this two is compulsory. And I'll tell you how to calculate. A moving average, well, let's look at this example. Moving averages of an odd number of results. So I'm going to name this as odd number. Odd number of items means the total number of data given to us is an odd number. Likewise, like this. So if we count 1, 2, 3, 4, 5, 6, 7, there are 7 items here. If there are 7 items, it is considered an odd number because it cannot be divided by 2. 7 cannot be fully divided by 2, isn't it? So, it is an odd number. I hope you know what is even numbers and odd numbers. Hence, moving averages for odd numbers are calculated in a different way, whereas for even number of items, it's calculated in a different way. Let's see how it is. So, let's try a particular question. Okay, let's try this question. So they are saying this is the annual sales given for a period of years. Calculate the moving average of annual sales over 3-year periods. Okay, so what you have to do is, now since they need 3 years average, you have to take the total of every 3 years and get their average. That's what you should do. Why you use every 3 years is because they are asking for a moving average. So it should move. That's why from every year it's connected. See, the first three starts from 2000 to 2002, including year 2001. But then from 2001 again we start to calculate the moving average until 2003. Right? So let's fill up the gaps. 2000, 2000 to 2006. 393, 860. Okay. Now I'm going to name this as for 3 years. And here also I'm going to name it as for 3 years. Okay. Take the total of these three first and place it in the middle of the 3. So the middle value of the 3 is 380 now. So write the total next to it, right next to the middle value. So the 3. Sum of these 3 should be written here. Then the sum of these 3 starting from 2001 to 2003, because we need 3 years and the answer of it must be written next to the middle value of the next 3 years. Right? This is how you do it. Likewise, continue. Next to the middle value, write your value, but make sure you include the every year. Now, can you take from 2005 onwards any 3 years? No, because there isn't any available data. Hence, you could ignore. Okay, so we have considered like as a starter, we have considered from 2004 to 2006 is the last set. Now, easy. We took the total for 3 years. Now we need the average for 3 years. What you need to do is simply take the total divided by 3. That's it. And write the answer right next to it. Okay? And take. So everything is divided by 3. This is how, so basically the answers are, hence you see this is all we need to do when calc for moving averages. That's it. But remember this method is followed only if the total number of items given to us is an odd number. Remember that. Now let's see how to calculate for even numbers. That means numbers that can be divided by 2 and 1 itself, or 2 or by itself. No, that's like by 2. Okay. So the same thing we will take as in the same columns, but let's look at a different example because this data set has only odd numbers. I'm gonna take a big one, a different scenario. This scenario. They have given sales for each quarter for 3 years, 2005, 6 and 7. For a series of quarters, they have given data of sales units. And they've asked us to calculate the moving average of 4. Okay, because sometimes they will tell us to calculate for 4 periods, sometimes they will not tell us. If they don't tell us, we must know, okay, why we need an average. First of all, it is because it is there's a cycle that is repeating. Because in year 2005 we have quarter 1, 2, 3, 4. Year 2006 again we have 1, 2, 3, 4. There's a cycle that is getting repeated. So that cycle period you can consider for the moving average calculation. Okay. Now since we have 4 quarters here, we can use 4 as a period. Okay, so I'm gonna use for 4 quarters over here, and I'm gonna read. This should be 4 quarters. Let me fill out the question. Okay, so I have now filled up the question as given. Let's now work out how the moving average for the even number of items. Now here, when it comes to even number of items, another thing we have to do extra when compared to moving averages for odd numbers. That is, you have to find the midpoint of the moving average you already found. Okay, average of moving average, and that will be the ultimate moving average for the particular quarter. Okay. Okay, so moving toward oh, I've missed a bit. I have a this should be here and this should be quarter. Okay, total of the first 4 quarters is this. But I told you as previously for odd numbers, we must write it write the total right next to the middle value of the particular set that we have selected. So the set we have selected here is 4. The middle value therefore is between these 2 and 3 quarters value. So I'm just gonna to make it clear, I'll insert a row so that you all know where to write it. So it's here, okay? It's in the middle between this and this. And then the other 4 quarters, you have to start from quarter 2 of 2005 to quarter 1 of 2006. Take your total, but this time it should be here. Isn't it? Because 2 here and 2 here. So it has to be again in between this. Right? So let me add lines to each section so that we don't have to keep adding as we go. So I've taken the total from quarter 2 and then from quarter 3 to quarter 2 of 2006. it is 2640, which I will enter here. Then 722 420 is 2640 again. I will enter it right next to the middle value. 2660. Two 690, 2730, 2740. And from 670 onwards, yes, we have one more 2760. And from 900 onwards, can I pull it till another 4 quarters? No, I cannot, because there isn't any other data given as it finishes from quarter 4 of 2007. So I leave it and stop. Hence, this will be my moving totals for 4 quarters. Okay. Now we should calculate the moving average for the 4 quarters. How to do that? Just like we did for odd numbers, same thing. Divide the total by 4. Okay. And write it right next to the total. So I'm going to copy paste the same to all. Okay. Now comes the new part, which is finding the midpoint of our moving average. So now we have to select two averages and find the midpoint of it. So what we have to do is add 645 with 655, and the entire thing you have to divide by 2 to find its middle value, which is 650, and write it next to the middle value of both. Okay. Same thing you have to do for the next set of two values. So basically you must select pairs or two values and get your midpoint. Okay. Select the two values and get the midpoint. Two values, midpoint 2, midpoint 2, midpoint. Okay. So for each you will get the midpoint as such, starting from 655 to 660, then 660 to 660 again, 660 again to 665, and so on. Alright. So one thing I missed to mention is that this moving average, therefore we can call it the trend. Okay, it's called the trend. And another name for moving average results, we can call it the trend of the particular data set, because moving average is a way of measuring trends. Okay. Now we can see how to draw this in a graph. So in the book they've mentioned how to draw this. So as you could see in this graph, you are not required to draw this in the exam, but you are required to understand how to read it. They have drawn the actual data sets or data points here based on this column, the actual column. Okay, the sales. And then they have plotted the trend, which is represented by the square marks. Now if you see the actual variation, it is very high, isn't it? See how it's going up and down and very high compared to the trend that is very near to a straight line. So why is this? It's because moving averages don't consider seasonal variations. It removes the seasonal effect from each quarter by getting an average. So, because of that, we really can't see the seasonal effect as we get an average for all 4 periods. Whereas actually we definitely can see the seasonal effects with the higher variations here. Probably in quarter 3 there must be a financial crisis or bad weather condition that may have brought the sales down. And see the same now quarter 3 in 2005 has low sales. Same like that, quarter 3 in 2006 also has the low sales. Quarter 3 in 2007 also has low sales. And if you take quarter 2 of every year, it has the higher sales. So, what do you think of these similarities? It means that there is a common seasonal factor that affects these sales every year. It can be a cyclical factor. That's why, because it is a common factor, when we remove that common factor off by getting the average, the line becomes a straight line. Because we removed the common seasonal factors off by the calculation of moving average. Okay. Now, when it comes to an odd number graph, odd number related moving average, the graph will consider, now the trend line will consider the points of these displayed in these column. 410, 430, 460. These only will be plotted by this square symbolized line, the trend line. But for an even number, remember this very well. For a moving average of an even number, what will be plotted into the graph is the midpoint of the moving average. Okay, it is not the moving average simply. It is the midpoint of the moving average that is called the trend, and that is the trend. So that's why we enter these particular data as the trend in the graph. Okay, so remember that difference between odd numbers and even numbers. So in summary, moving averages are of 2 types, odd numbers and even numbers, and that odd and even depend on the or is identified on the number of items of data given to us. Alright, next let's move to seasonal variations.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.